Right, is this morning's video. Let's see how clever you are. Lots of junk on the table, lots of stuff not doing nothing. Basically, I got one earth going off there and I got one earth going off there. I've got a magnet, so if that ends south, that's north. So all of that nail is north, so it's accelerating to a point of infinity, which is the nail. And if that one's Vicky Verky, then that one's south, accelerating all that way. So right in the middle, as you can see, they're void from being touched because I've put a piece of balsa wood in there. But the two charges are hitting an infinite point. They can't join, so they're ricocheting up and down the iron because iron is magneto-infinitive. And you've got an LED lit up, okay? Now, if you know anything about LEDs, you'll know that they come at different voltages. And this one, which I've got in my hand, which is a 15mm LED, has got a potential voltage maximum of 12 volts. Anything above that, you'll fry it into next week and you'll get no joy. You can get it to illuminate slightly lower than that voltage, but there's really no much point if you can only get 12 volts DC off it. So there we've got our LED lit up, nice and bright, off two 6-inch nails. The copper wire is for another little thing that I'll show you later. If you think we've now got a resonance frequency going backwards up and down this wire, just like you get in a motor where you spin the magnets with inside a copper coil, here we have a stationary magnet and stationary copper, and we're just using two earths. Now I'm taking the plus and minus anode and cathode off each side, and they go across my legs just for the sake of it, and onto two cables, and they come up to the AVO, and we've got 86 volts. Okay, that's 86 volts DC from an LED. By all laws of physics, engineering, mechanics, that LED should have gone fuck off into next week. But if we now put this into an AC mode, because an LED can't work in AC, right? We've actually got 81 volts crossing an LED as an AC supply. So this little process will make an AC and DC output of 86 volts from one LED. So what's this bit that you need to spin a motor to make electricity? You spin the motor because you're using fuel. You're using fuel because the oil companies want you to use fuel. So they're forcing you to use the fuel to spin the motor to make the electricity. This motor here, this magnetic motor, is not moving. It's stationary. And it's generating its own electromagnetic force within inside itself and generating its own voltage within inside itself. Yes, it is only an LED, but it's better than anything that NASA or MIT or CERN have managed to produce. Now they spend billions and billions and billions of your money on nothing. Here is a very simple example that you can do for yourself, and you can create your own light or energy. You can now take these two circuits off. I don't want to touch them because you'll get bit, because it's electricity that's going across them. You can take them two off to a capacitor, to a supercapacitor, and store it at 2.7 volts, go up to serial, get up to 15, at maybe 40,000 farads, and then you can power an AC inverter to create 220 or 210 volts, which creates the EMF that you're looking in front of you. So it's a self-driving motor. And the only reason we've got the silicon is to assure that nothing goes to earth and everything is locked within inside its own circuit. I can't make it any clearer than that. So absolutely nothing faked whatsoever, right? All the way along. No hidden batteries, no hidden bollocks. This, you ought to know me by now. Just a pair of magnets, iron, which is magneto-infinitive, one north, one south, goes to the middle, wants to jump the gap, can't jump the gap, creates an EMF, tap the EMF off to a voltmeter, or tap the electron current off here. That's how simple it is to make. Okay? But if you want the big ones, the ones that produce the 1 kilowatt and more, then you're going to have to think, and to do so you're going to have to go via Gaia. Okay? Thank you very much.